Here's number 16 from 4.1. We have a function f of x is equal to the secant of x on a closed interval from negative pi over 4 to positive pi over 3. We're asked to use the candidate's test to find the extreme values of this function on the interval. So the first thing we need to do is decide whether we have any critical numbers inside of our interval. So we need a derivative, and the derivative of the secant function is secant of x times tangent of x. We'd like to know where this function or this derivative of the function is either 0 or undefined. And the way to do that is to rewrite this function in terms of sines and cosines. So we know that secant of x is the reciprocal of cosine. So here's a cosine x in the denominator. And we know that tangent of x is the sine over the cosine. So I'm going to write a sine x in the numerator and another cosine x in the denominator. So here we have secant of x tangent of x is equal to sine of x over the cosine squared of x. This fraction will be equal to 0 when the sine of x is equal to 0, and that occurs only at x equals 0, and that is going to be inside of our interval, negative pi over 4 to positive pi over 3. It would fit almost in the center. The denominator will be 0 when the cosine of x is 0. The only places I can think of that would be close to our interval where that happens is at x equals positive pi over 2 or at x equals negative pi over 2. And neither of those x values are inside our interval. They lie to the left and to the right of this interval. So that means the only critical number with which we are concerned right now is x equals 0. So let's set up the candidate's test. It's an xf of x table, very similar to our xy tables from algebra. We're going to list first the left endpoint of our interval, negative pi over 4, then the critical number that occurs in between, and finally the right value of our endpoint, positive pi over 3. Now we need the y values of this function. So first, f of negative pi over 4. So that's going to be a secant of negative pi over 4. And I don't keep secants memorized, but I try to do my best to keep cosines memorized. So I know this is the same as 1 over the cosine of negative pi over 4. Well, the cosine of negative pi over 4, that's a fourth quadrant angle, and the cosine there would be a positive square root of 2 over 2. So the reciprocal of that is 2 over root 2, and I know that I can rationalize this into a 2 root 2 over 2, or just the square root of 2. So the value on the left side is root 2. Next, f of 0 is going to be a secant of 0, which once more is the same as 1 over the cosine of 0. Since cosine of 0 is 1, this is 1 over 1, and I have a value of 1 for f of 0. Last, we have f of pi over 3. F of pi over 3 will be the secant of pi over 3. Again, that's 1 over the cosine of pi over 3. I know that my cosine of pi over 3 is a half, so I'm looking at 1 over a half, which turns into a 2. So the smallest of these values is the absolute minimum. The largest is the absolute maximum. It's pretty easy to see that we have a maximum value of 2 at pi over 3. And then root 2 lies in between 1 and 2, so that means 1 is our minimum value. So we're going to have as a final answer here an absolute max of 2 at x equals pi over 3. And then we're going to have an absolute minimum of 1, and that's going to occur at x equals 0. And that does it for number 16.